And tonight we will go over, we just did our exam review. I didn't record it in case you're watching this in the future and trying to cheat. Don't cheat. Cheating's bad. We're going to talk about how we solve problems, because I think that was the problem. All in all, I think the syntax, y'all got the syntax. Y'all know what the data types are. You know when to use the right data types, all that good stuff. You know how to insert things into a list. But the challenge is understanding when to take these puzzle pieces and use them, and how to put them together in the right way. So I spent today trying to I've been thinking about it since the exam, trying to think about how do we teach this skill of solving problems. So what did I do? I Googled, how the hell do we solve problems? And I found a really good blog post. So if you're interested in reading this in full context, there's a Hacker Noon article by Madhav Bal, I think. I don't know who this person is. I actually emailed them today because I really like the article, saying, hey, guess what? I'm going to use your article in my class. What he does, he talks about the 5 steps to solve problems. I went through probably 36 articles trying to find the right, something that would be relatable. And I think he did a really nice job in this article. So this is a good one for you to read, but I want to go over and kind of summarize. The 5 steps that he talks about are understanding and analyzing the problem. Go through sample inputs and examples thoroughly. This is very applicable. He talks about competitive programming, so things like HackerRank, do competitions. There are a bunch of other competitive programming things. I know that sounds super cheesy, but it's a thing. And so these are kind of the steps that, you know, when we've done HackerRank stuff that I've led us through, these are the steps I go through. So understand and analyze the problem. Look at the sample inputs and the examples thoroughly. Break down the problem. Like, look at your problem and break it down into steps. Then you solve it. And then you can always look back and make it better. So a little more detail. So understanding and analyzing the problem. Read the problem. Read it a bunch of times. Ask yourself, do you understand what it's saying? You know, when I say find the runner-up, do you understand what the runner-up means? What are the inputs? What are the outputs? Like, what am I expecting as an output? Am I expecting you to print something? Am I expecting you to return it from a function? Am I expecting you to write something to a file? Like, that's the output of your program. Do you need more information? So do you not have, like, are there questions that seem ambiguous? Or I'm not quite sure what he means when he says runner-up. Like, let me call him real quick, or talk out in Zoom. Like, what do you mean runner-up? What does a runner-up actually mean? If you can't determine it based on the declaration and the inputs. But these are kind of the taking the time to look and really understanding what you're working on. This is a great quote. The programmer got stuck in the shower because the instructions on the shampoo bottle said lather, rinse, repeat. And why did we get stuck? Because then we lathered, rinsed, and repeated. And then we lathered, rinsed, and repeat. So we get in this infinite loop. Sample inputs and examples. So going through some sample inputs and coming up with more examples of your own to try your solution against. And it gives you a way to find like edge cases and to find out how your code should handle. Ranges of inputs and outputs are important when we're dealing with these interfaces. So start simple. Start with simple examples and find the outputs. So then take more complex answers, bigger answers, more input, larger things. So you saw in all the HackerRank stuff, like the example for when we were drawing a doormat was like a 10 by 4 character doormat. The challenges eventually got up to 3,000 characters wide, 1,000 characters tall. Like, they got bigger as time went on. And those are the varying levels of testing your application. Edge cases are critical for programming safe applications. So when you write a function that says, find me the runner-up of scores, right? You would expect to get a list of scores, and those scores would probably all be positive numbers. There's probably one or more And so the edge cases are things like, well, what if there are none? What if it's a none list? What if there's no list to check? What if there are no values in the list? What if the values are negative numbers? What if the values are floats? What if the values for some reason are strings? So those are your edge cases that you're looking for when you're trying to determine how your application works. And so some very typical edge cases are what happens when there's no input or invalid input. Like if I'm looking at runner-up scores and one of the values is dog, that's not a score, so what do you do? Then break it down. So when I start to think about solving a problem, it's usually multiple steps to make a problem work. And so in my head, I think, okay, well, if I'm trying to find the runner-up of something, to find the runner-up, I need to figure out the highest number. So I'll do that first. Once I know the highest number, then I'll look for the next highest number. So that's kind of the flow in my head to help me to solve this kind of a problem. So breaking it down to sub-problems or smaller problems can really help break that down and then connect them all together. So the fourth bullet, he mentioned classes and objects, and we haven't really talked about object-oriented programming at all yet, but we will. That comes to how do we encapsulate data and functions into something called a class. And once you go through that exercise of understanding your problem, breaking down your problem, and solving the problem, and having a plan to solve the problem, that's when you can actually start solving the problem in code. And so what I wanted to do was take a couple of examples, starting with that exam question, and go through those steps to just build that muscle of how we can solve these kind of problems in code. So let's go here. I'm going to start. I'm just going to use the online Python thing as my scratch pad as well. And what I want y'all to do is help me figure out how to do this. So the more interaction we have, the better. So we're looking to find the runner-up score. In today's sports tournament Go Sports, we need to write a function that accepts a list of scores. Your function must find the runner-up score and return it. So first off, do we all know what that means? I guess even I made the assumption that everybody understands what a sporting event could be, why we would care about a runner-up. Like if we were talking about a swim meet, you have multiple people, not just a winning and a losing team, but you have multiple people with times. You'd look for the winner and then the runner-up. Car racing would be the same thing. You'd have multiple cars, not just a winner and a loser like in baseball, but you would have multiple scores and the runner-up would be exactly right, the second to highest score. Does everybody get that?
Yeah, that makes sense.
Okay. And so, and I think we just, that figures out, Jaleel, like finding the second to highest score. How do you do that? What are there are 2 steps to do that. I think 2 steps. Yeah. So the comment is we'd eventually have to sort the list. I would argue we don't have to sort the list. Yes, the first step in the process. So the big differentiation here is what is the mental step, regardless of, not a coding thing at all. Like if I put a list of numbers in front of you, how do you find the runner-up number? You can't sort things. It's inscribed in stone. The first thing you have to do, regardless of how you do it, the first thing you do is find the highest number, right? If you don't know the highest number, you can't find the second highest number. And a lot of you, yes, way overcomplicated this. So step 1, find the highest number. Step 2, find the second highest number. Is that it? I mean, we could add a step 3 of return second highest number because we're dealing with functions. But not talking code, not talking data structures, not talking sorting, slicing, duplication. Yeah, that's right. These are the steps. Now we have to figure out, now that we know we have this mental picture, right? This is my mental flow chart. Given a list, I need to find the highest number and then find the next highest number. So let's figure out how to do this in code. Well, even better. Second step, look at the examples, look at the inputs and the outputs. I probably did a disservice by having these in an order, but they didn't have to be. So let's walk through that in our head. What's our highest number?
The 330.
330. What's our second highest number?
The 100.
100, exactly. So we return 100. 100 is our runner-up. We're humans and smart. We can do that really, really quickly without someone telling us an algorithm on how to do that. But here's where the different examples come into play. Same straightforward. Highest number is 4, second highest number is 3. Okay, so I know my process still works. Now here's an interesting example. What's my highest number?
1.
My highest number is 1. What's my next highest number?
1.
Nope. So, and this is again going back to these examples, and actually this example as was written first showed this, I think, better. When you are at a sporting event, like a car race, or a foot race, a swimming race, if people tie, they both win. They both come in first place. So in this case, they all tie for first. My runner-up is 4. Does that compute?
Yeah, that makes sense.
Okay. So given that, now I can look at this one. How many people won? Everyone. 5 people won. How many people were runners up?
None.
None. What's my second highest number?
None.
And that's why this should return none. Same with the next one. What's my highest number?
None.
What's my second highest number?
None.
Exactly. So I think our algorithm works. So we've tested it against a whole bunch of inputs. And that's why I gave you a whole bunch of inputs. So now let's go back to the programming part. I'll do it up here so it's closer. Okay. I want to keep track of this because this is important. All right. Rubric. Function must be called find runner up. How do I make function? %. Got it. Function must have one required parameter. That will be a list. Incoming list. I didn't prescribe a name, but now I have a required function. Those 2 lines of code, now I have 40%. I put in pass just so it would compile. Remember, that's a no operation. Okay, function must return the runner-up score. Okay. Let's figure that out. So we're programming functions return a value in the form of a variable. Let's make a variable. Runner up score equals none. We'll give it a default and we'll return that. I wouldn't have given you credit for that, but that's the start. So now within my code, let's do these steps. Going to the steps up here. When we do software development, this look back and learn more steps, we call that optimization. We call that simplification. We call that refactoring. There's a whole bunch of stuff. That comes after you get it right the first time. When you write software, you typically write it 3 times. The first time you get it right, you make it work. The second time you make it better. The third time you start from scratch with lessons learned from the first time to make it simpler, faster, and better. That's just naturally how we write software. So, step 1, find the highest number. What's the easiest way of finding the highest number that you can think of? There are a million ways to find the highest number. Sort and pick the highest. Okay, that's one way. I'm going to write that as an option. What's another way? Is there some sort of max function? Great question. I'm going to write brute force find highest number. Let me show you what that looks like. I'm going to have a variable, highest number. I'm going to assume in this sporting event, every score is positive. Maybe I'm not comfortable with that. Let's make this a really, really low number. The reason I'm doing that is now I can say for score in incoming list, if score is greater than highest number equals score. I just found the highest number. Really simple. I just looked at them all. Or you could have done highest number equals sorted incoming list 0 or whatever, however the syntax of that is. That could have worked. But here you have to deal with empty. You have to deal with you have to deal with empty or none, but you can do that with some. Let's do that. If not incoming list equals there. Okay, now I've dealt with empty. I've dealt with empty, so that's cool. Oh, but if there's no runner up, then it must return none. So if there's, I know there's not going to be anything, so I'll just return none. So if there's an empty list, I'll just return none. All right, going back to here. Highest number equals max incoming list. Those all work. And to show you, print highest number. I'm going to print the highest number 3 times. And I'm going to call it with this one. What is it called? Find runner up. Find runner up with that as my list. Run. Ooh, okay. So I'm doing some experimentation. My first one worked, my last one worked, my middle one didn't work, so I'll reverse it. Is it reversed or reverse? There we go. Okay, cool. Any of those would work. That is a super simple way of finding your high number, right? Somebody's got a nod. Okay. Which one do you like the best?
I like the max one the best, to be honest.
Cool. So
That's the most straightforward.
Yep. So I'm going to comment the rest of them out to keep them for your reference. But because Python is awesome, there happened to be a max function. So now I got 5. Now how can I find my next highest number? This is a little harder.
Could, before you find your max, like put it into a set instead of a list, because that would get rid of your duplicates.
Yep. That's one way of doing it.
You could do like the negative, oh no, sorry, I guess the negative second or something, I don't know. But that would be with sorted.
Yep. That is a great observation. So what Caitlin is saying, I could do a set of numbers equals a set of incoming list. Now I have a unique list. So instead of 555, instead of 4 5s, now I only have 1 5. Okay, then I want to turn that back into a list, right? Then I want to sort it. So that's the answer in 1 line of code. I didn't expect that from anyone. If you gave me that, great. But that's what I mean. The answer is using data structures and having the knowledge of the data structures, knowing that a set is a unique list, knowing that then you have to put it into an ordered list. Like, that's a great answer. Would have gotten credit. But I think the simplest way, or maybe not simplest, the least complicated way of doing this is another brute force. So if we do this again, we can do something like lowest number equals -99999 for score in incoming list. If score is greater than lowest number and score is less than highest number, lowest number equals score. If lowest number equals -9999999, make sure I get the same number, then I know I didn't have a lowest score. Return none. Otherwise, return lowest number. I think that should work. not lowest, runner up. Does that work? Now let's see if that works with all of our examples. Maybe not all. I'll go to the big one. There's the big one where I know I want 100. And here I'll trick it with the empty. And then here is one I know is going to break. But that's okay. We'll test it. We'll see where it breaks and we'll fix it. So I'll run that. Oh, it didn't break. I fixed it. It worked. Okay, cool. So 4 was the first one. Yep, that was our runner up there. 100 was the next one. None was that one. And none was 3. So, now let's just check on a none. So that's another way of doing it. So I checked the scores the second time, seeing if it's bigger than the lowest number so far, but less than the highest number. Because if I didn't check for the highest number against the highest number, I would have just gotten the highest number again, and that wouldn't have been the right answer. So I had to make sure it was less than the highest number. This is the brute force, absolute slowest way of doing this. But that's okay. It solved the problem. Did everybody follow that?
Makes sense.
Who did I lose? And it's okay if I lost you because we can do it again or go to other examples. If you want to hear other examples, tell me. Other examples.
Maybe another example would be nice.
Okay. Another example. I'm starting to eat a clementine as we talk as well. All right, this is where I'm going to go to my favorite HackerRank. HackerRank.com. And this time, though, instead of jumping down to something that looks fun, I'm going to start pretty high up at the beginning. That's not... Guess where I got that example from. I'm not creative. Okay, these are all still easy. Let's go to... Well, no. Let's start at the top. This is math. We'll do it all. We'll start up here. All right. So what was step 1 of our 5-step process? It might be small now, but I want the code bigger. Step 1, understand and analyze the problem. Okay. In HackerRank, that is our task. So if we look at our task, given an integer n, perform the following conditional actions. If n is odd, print weird. If n is even and in the inclusive range of 2 to 5, print not weird. If n is even and in the inclusive range of 6 to 20, print weird. If n is even and greater than 20, print not weird. Pretty straightforward, right? Yep. Well, so just a bunch of elif statements. Do you see anything in there that says otherwise or else? Like really look at this literally. Each 4 line is just an if. So we're just doing 4 if statements, I think. Okay, so here is the wrapper code that they've given us. We don't have to worry about the input to get the number we're testing. They're doing that for us. Did it even say write a function? Given an integer, perform. It said nothing about a function, so we don't even have to write a function. So here's my notes on what we're going to do. Okay, if is, there should be an n in all of these. If n is odd, print weird. How do I determine if n is odd?
It's divisible by 2.
How do I determine if it's divisible by 2? Yes, that's the answer. Modulus, yep. Okay, so if n modulus 2, so if the value of n was 11, what would modulus 2 equate to? Does anybody remember what modulus does? Gives you the remainder. Exactly right. Returns the remainder. Yep. So, if the remainder is what? It's odd. Try it out in our head. 4 modulus 2. What's the remainder? 4 divided by 2. 0. So if n mod 2 equals 1, that's an odd number. Print, come on, weird. Okay? If n is even and in the inclusive range of, those didn't copy either, 2 to 5. 2 to 5, 6 to 20, 2 to 5, 6 to 20. And I think the last one is greater than 20, right? Okay. Greater than 20. Okay. If it's even, so how do I, if it's even? N mod 2 equals 0. Yep, good job. Is 0. And, inclusive range of 2 to 5. N is greater than or equal to 2, and n is less than or equal to 5. Print not weird. That seem right? There could be a cool Pythonic way of checking if it's inclusive in the range of 2 to 5. Yes, China, we could do that. We could do, let me answer those two in question. So yes, we could do if n is in range 2 to 6. That's the same thing, because 2 to 6 gives us 2, 3, 4, and 5 as effectively as an array. So we see if 2 is in that array, or n is in that array. Perfect. But you cannot do the syntax of 2 is less than or equal to n is less than or equal to 5. Like, that syntax just doesn't work. You have to compare each part. But good thought. When you tried to run that code, you would see very quickly that it wouldn't work. So yeah, that's another way of answering it. Okay, so the next step. If n is even and in the inclusive range of 6 to 20. N is even and n is in, I like this format, n is in the range of 6 to 20. 6 to 21 because range is an exclusive range. Print weird. If n is even and n is greater than 20, print not weird. Did I miss anything? Let's see what happens. So one thing that I think would build everyone's muscles, your Python muscles, is do this. Go to HackerRank and find stuff. Let's do more. The provided code stub reads two integers from standard in A and B. Add code to print 3 lines where the first line contains the sum of the two numbers. The second line contains the difference of the two numbers, first minus second. Ooh, that was poorly worded. The third line contains the product of the two numbers. Okay, we can do that. So they want 8, -2, 15. Input format, we don't care about that stuff. So I'm taking this down here again. The first line, okay, contains the sum of the two numbers. So how do I print the sum of two numbers? Print A plus B. The difference first minus second. The reason I said this isn't good is because it should have said A and B, but that's okay, in my opinion. A minus B. And then the product. Print A times B. Oh, I don't want Python 2, I want Python 3. Ah. Let's see, where's my congratulations? The provided code stub reads two integers, integer A and B. Add logic to print 2 lines. The first line should contain the result of integer division, A divided by B. The second should contain the result of float division, A divided by B. No rounding or formatting is necessary. Cool. I will be printing 2 lines. The first line will do that. The second line will do that. So, I have my 2 integers. These are too easy. Yes, I agree. I'll do this one more, then we'll move on. Print integer division. A divided by B. Now, let's say I don't know if that's integer division or not. Print A divided by B. I don't know if that's integer or float. I'm going to run it and see what happens. My output 1.333 and then float. Okay, so the floats was expected but not the integer. How do I make this integer division?
I think, isn't it like it's like a double slash?
Let's see. Come on now. Maybe. While we're waiting, I'm going to test that. Looks like it. Nice. I didn't actually know that. But they did tell us that up above. Okay, cool. That was too easy. Let's go to a harder one. Why aren't that letting me click on there? Give me this one. All right, cool. All right. Practice. Easy, medium, or hard. Let's do a medium. We've done the minion game. What the? Let's not do that. Ooh! Totally remembered something. They have a problem-solving practice. There we go. Birthday cake candles? You're in charge of the birthday cake for a child's birthday. You have decided the cake will have one candle for each year of their total age. They will only be able to blow out the tallest of candles. Count how many candles are tallest. Okay. Candles 4413. The maximum height candles are 4 units. There are 2 of them, so return 2. Complete the function birthday cake candles in the editor below. Birthday cake candles has the following parameters, blah, blah, blah. Okay, cool. So we have to make this function, birthday cake candles, and we have to find how many are the tallest candles. Does everybody understand the problem? So the example here, if there are 4 candles, one of height 3, one of height 2, one of height 1, one of height 3, the 2 tallest are 3. Or the tallest is 3, and there are 2 of them. Here, the 2 tallest are 4. The tallest is 4, and there are 2 of them. So what are our steps to solve this problem? This is super simple, or super much like our runner-up one. Find the tallest candle. Yes. Step 2. Find how many tallest ones there are. Count the tallest number. Yeah, exactly. All right, so tallest candle. We've already done the other one, so I'm just going to find the max of the candles. Right? That's my tallest number. How can I count a value? I don't know. Let's brute force it. So number of tallest, we'll start a counter. For candle in candles. How can I tell if something's the tallest? Or how do I tell if this candle is as tall as the tallest? That's the way to say it.
If candle equals tallest candle, add 1 to the counter.
Yep. Number of tallest plus 1. Return number of tallest. Typo in row 24. Uh-oh. If candle equals tallest candle.
Yeah.
Thank you. So now, coincidentally, unfortunately, we're building a muscle. We're figuring out common ways to solve a problem to make our building blocks, and then we can start using these building blocks. So that one was easier than I was expecting, but it was good. I don't want warm up. We don't want warm up. We want, oh my lord, maybe we do want warm up. Implementation. Migratory birds, that sounds fun. Watch it be the same kind of problem. You have been asked to help study the population of birds migrating across the continent. Each type of bird you are interested in will be identified by an integer value. Each time a particular kind of bird is spotted, its ID number will be added to your array of sightings. You would like to be able to find out which type of bird is most common, giving a list of sightings. Your task is to print the number of that bird, and if 2 or more types of birds are equally common, choose the type with the smallest ID number. Interesting. Example. Assume your bird sightings are of types array 1, 1, 2, 2, 3. There are 2 types. There are 2 each of types 1 and 2, and 1 sighting of 3. Picking the lower of the 2 types is type 1. So this is almost a combination of our candles and our runner-up, right? So let's figure this one out. Complete the migratory birds function in the editor below. It should return the lowest type number of the most frequently sighted bird. Okay. I'm going fast and I need to get out of that habit. Does everyone understand the challenge? Does anyone not understand the challenge? Hans got it.
Got it.
So let's use this as an example. Let's go down here in migratory birds. I have an array. What are my steps to solve this problem? Not code, not data structures, not nothing. What is step 1? Find the mode or modes of array. Okay, I haven't been in college in a long time. What's a mode of an array? The most common number. Okay, how do we do that? But that's right. Step 1. Find the, I'll even write mode of the array. Step 2. Find the lowest number sighting ID out of the highest modes. I don't know how to say that right. I want to break this one down now. How the heck do we do that? What's the first step in doing that? Count each unique number? That's not a valid description. I don't like that. Find unique numbers. Then we count them. Identify numbers with the biggest count. So now the question comes, how do we break this down into functional programming steps? How do we get a unique list of numbers? We did it quickly in our runner-up example. A set is a great way to do it. Unique numbers, why not, is a set of the array. Okay? Now I have my unique numbers. How can I count each number?
If the item is in your list, add one, like have a counter and add one. If that item in your list is in the set, add one to a counter.
Okay, so I like where you're going with that. There's a flaw, but I'm going to show you what the flaw is. So let's say for each number in my unique numbers, I need to count how many times it's in my list, right? Times in list, we'll start with 0. So I could say if num in array, that's only going to tell me if it's in there. It's not going to tell me how many times it's in there, right? So brute force for internal number in array, if num equals internal number times in list plus 1. So this is where visualization of our data sets really, really helps. Unique numbers is a set. I can iterate it. I can say for each number in that set. Cool. So I'm going to deal with each unique number in my set. Then I want to compare it against every number in my array. Array is the incoming array. So I'm just going to call that internal number. So for every number in my unique numbers, compare it to every number in my initial array. And if they're the same, increment a counter.
So when I was thinking of starting it with the array first, like for the number in the array and compare it, that would work too.
And these are two, that's even harder. Well, not really, but I'll show you what you're trying to do, and it perfectly works. For internal, I'll use the same variable names. Number in array, right? If internal number in unique numbers times in list plus equals 1. But where's my times in list bound to? Like, do I initialize it here? In that case, it never goes back to 0. Do I initialize it here? Then we're only counting it per time in the incoming array. So these aren't quite right, but this process kind of works as well. The problem we're going to have with both, and I'm gonna go back to my original just to there are efficiency reasons, but we don't have to talk about that yet. I still need a way to track this. So number in my unique numbers. Let's say as an example, array equals 1, 1, 2, 3, 3, 3, 3, 5. All right, that's my incoming array as an example. My unique numbers, what's my unique numbers? 1, 2, 3, and 5, right?
Right.
Thank you. Name the list after the number we're tracking each time. How would I do that? I don't know what the numbers are when my code is generic. It's going to work when there's 7,000 numbers in there. Imagine there were 7,000 unique numbers in there. I can't. Yeah, so you're getting somewhere. Now you're thinking about using a string to store this. What data sets or data types have we talked about that may have a key value pair?
Dictionary.
Thank you. Now we're getting somewhere. So let's say we have a new dictionary. Total counts. When I'm done, I want total counts for the example above to look like 1 has 2, 2 has 1, 3 has 4, 5 has 1. The key is going to be the number, the unique number I'm looking for. The value is the number of times that is in my incoming array. Dictionaries are fantastic data types for counting or bucketing things like this. So if I have a total counts dictionary, where in here, how in here do I track that in my dictionary? I'll start on a hint. We're going to do that, whoopsie, on line 26. How many times do I indent? Because my line of code will look like this. Total counts of my number, which is the one from my unique numbers, equals times in list. So, do I indent 1 time, 2 times, 3 times, 4 times? Where's the second, where the second 4 is? Here. That is the right answer. Now, to be technically accurate, here would be a decent answer too. It would work, but it's much less efficient. But yes, this is the right answer. So when I'm done counting how many times num appears, which is this block of code, then I'm going to track the total times in list. So when I'm done, this is exactly what my total counts dictionary is going to look like. So we have just done step 1 was find unique numbers. We did that. Step 1.2, count each unique number. We just did that. Now we need to identify numbers with the biggest count. Where did we store the count?
In the dictionary.
Is it a key or a value?
Value.
It is a value. Okay. So, we're looking for the biggest count or highest count or largest count, whatever the right technical number is. So, make a variable. Largest count equals 0. Default to 0. How can I now find the largest number in my dictionary? I'm about to pick on somebody in my list. Hans, how do I find my largest count in my dictionary? Oh, he's going to ignore me. Drew, how do I find my highest count in my dictionary?
Max?
If it were a list, maybe. But now I'm curious. Python 3.8 max function. This is 3.9, but that's okay. Let me see what that max function does. It looks for an iterable. Return the largest item in an iterable or the largest of 2 or more arguments. Okay. We can do that. Largest count equals max of my total counts. Now, when we iterate a dictionary, like a for loop, if I did for x in total counts, what would x be? Would it be the keys or the values? Does anybody remember? All right, the answer is keys. What am I trying to find the max of, the keys or the values? The values. So there's a function on a dictionary to give me a list of values. So this actually should work. I'm gonna test it real quick though. Largest count. See what happens. So the input 144453. Largest count is 3. Oh, that didn't work. Oh yeah, that did work. Because there were 3 4s. Awesome. So I don't need to initialize it. I've identified the largest count. So I guess really that's step 1.3. Identify largest count. Then we can identify numbers with the largest count. Okay, how do we do that? If someone says brute force, that's a cool answer. Come on, somebody say brute force.
Brute force.
Thank you, Drew. What does that mean? Just kidding. So now I want to check every number in there to see if they're the highest count. So for x in my dictionary, x is the keys. X is a key. I need to check if the value is the same as my highest count. So if total counts x, that gives me the value equals largest count. X is one of my numbers. Well, shit, what do I do now? What do I do with x? How do I keep track of my... Remember now, I'll even break this apart. Let's identify the numbers with the largest count. Let's cheat. Numbers with largest count. We'll make it a list. So now I will append x. So now when I'm done this, numbers with the largest count will have a list of numbers in it. Find the lowest number out of the highest modes. So my unique list of numbers with the highest mode is in here. How do I find the lowest number?
Min.
Thank you. Okay, now that we've done that, we have more muscles in our muscle box. Tools in our toolbox, that's better. Now we know how to find the largest value in a dictionary. Now we know how to find the lowest number in a list. And therefore, by process of deduction, how do we find the lowest value in the values of a dictionary? We change max to min. How do we bucket or count unique values in a list? Well, we used a dictionary to count them. Another tool in our toolbox. So now we're getting a bunch of tools to build the next challenge, right? I'm going to keep that code. I want to keep that code. Where do I keep that code? I know where I'll keep that code. There, I'm going to keep that code there. Okay, so we got that one right. Let's see, we are 8:43. One more? No more? I'm done?
One more.
One more. Watch somebody in comment. Oh, yeah. Oh, that's the thing about HackerRank I really absolutely hate. If we go to like the group, or what do they call it? The discussions about this. We wrote this in 47 lines of code. We could have done it better. Probably. Like, I'm sure we could have made it somewhat better. Well, we had a bunch of comments in here. So if we took out our comments and cut down our white space, but following TEP 8 standards on how to separate your stuff. We did this in about 12, 31, 19 lines of code. That's not bad. If we go to the stupid discussions, it's going to be like 2 lines of code, and I'm going to hate them all. Four lines of code. Jerks. Exactly. The elegant solutions. This is never mind. I can't say that without being insensitive. It's the nerd version of comparing big trucks. That's gonna be on YouTube, so whatever. Let's see. Let's go to another one. That one was fun though. I kind of like that one. Migratory Day of the Programmer. Let's look at these success rates. So that success rate was 91%. 89 is the lowest I've seen so far. Ooh, forming a magic square. Do we want to try a harder one? Medium. 74%. We can totally do it. We can totally do it. Oh, Lord. We define a magic square to be n times n matrix of distinct positive integers from 1 to n squared, where the sum of any row, column, or diagonal of length n is always equal to the same number. Holy crow. If we given a 3 by 3 matrix in inclusive, we can convert any digit A to another digit B in the range at the cost. Nope. We'll do that another time. Is this
how they make Sudoku puzzles?
That's exactly right. It's crap like that with math and whatever. I like electronic shops. The problem is I don't want to just do another one that's exactly the same as the one we just did, just labeled differently. A person wants to determine the most expensive keyboard and USB drive that can be purchased with a given budget. Ooh. Given price lists for keyboard and USB drives and a budget, find the cost to buy them. If it is not possible to buy both items, return -1. Oh, this could be fun. Is this fun? This could be fun. So here's an example. Our budget B is $60. Keyboards there's an option of $40, $50, or $60. And the USB drives are $5, $8, or $12. So without reading this line, what's the most expensive combination we can buy? Humans are smart. We can do this in our head really quickly. 60 and 12? No, we can't buy that.
58.
50 and 8 would be 58, yep. Or 40 and 12 would be 52. Within the budget, yes. So 50 and 8. That is the correct answer. A person can buy a $40 keyboard, $12 for 52, or 50 and 8, 58. Choose the latter and return 58. Cool. What's the first thing that comes to mind as far as code goes? Anything? Three lines of code. 4. The fourth is a return statement. Stupid, all the additions, pick the best one. So comment, stupidest one is to do all additions and pick the best one, but it's not scalable. That's exactly the right answer. I think. Scalable? That's step 4 or 5. We do that later. So let's figure that out. Okay. Get monies spent. Keyboard is an array. Drives is an array. B is our budget. Okay. How do we do this? For loop with both lists. Awesome. For keyboard in keyboards. For drive in drives. We can do that. All prices. Oops. All prices append drive plus keyboard. Return max all prices. I went through that super quick without going through our steps. God, I'm bad at this. What's step 1? Find all combination prices. Step 2. Take out ones not in the budget. Step 3, return to max. How can we combine 1 and 2? That are in the budget. That way we don't take out anything. So, step 1, find all combinations, return to max. So how do we that are in the budget? If budget blank 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 drive plus keyboard what's blank 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 if budget less than the other way around. Correct. So if I do want to append it, budget has to be greater than or equal to drive plus keyboard.
Would we just use B instead of budget?
Oh, thank you. I think that's it. max arg. Ooh, on an empty sequence. Okay. So was there something that said they could be an empty sequence? Oh, come on. Why isn't you scrolling up for me? My computer locked up. I can't scroll anymore. But my mouse is moving. Maybe it didn't. Maybe it's just a stupid program locked up on me. So I need to make sure all prices is not null or has elements in it. If there's no elements in it, I need to return a -1. So I could return the, yeah, I'd have to do that. Well, my computer's done. It doesn't want to play anymore. Oh well, but that was how we do it. That was a really very straightforward one. But the steps, the reason I skipped those steps quickly is just because I've been doing this a really, really long time. And it's not an intentional habit I go through. The same steps happen in my head. I just do it really quickly because my toolbox is pretty big when it comes to programming. So having those steps for y'all on these challenges or on the exams or quizzes or whatever, that can help. And so the way of doing it, writing a line of comment saying, and here I'm going to do this, and then I'm going to do this. Then we figure out how we do this and that. So identify your steps, then figure out how to do those steps.
Essentially like showing your work in a math exam.
Exactly right. I just don't give credit for it. But yes, exactly right. Because you're not in 3rd grade either. Yeah. No, but you're exactly right. It's you're building your blueprint before you build a house. What happens when you build a house without a blueprint? How big is this bathroom supposed to be? Were there supposed to be 2 floors on this house or 12? I forget. Right? Not a good idea. Okay, let me go to... Where did my slides go? Where did my slides go? All right, so this blog post is linked in the slides. I thought it was funny. I would love to get this sticker. Keep calm and start coding. But full credit to this dude for writing a really good blog post. And that's what he looks like, I guess. Madhav. You will have some homeworks. So we did all that. And then we have a homework. Before I read the description, don't read the description. Look at me. Listen to me. This is hard. I don't give a rubric, but I want you to give me the steps you're going through to try to get the answer. So, unlike my 3rd grade comment, I will give points and credit for giving me steps. Because this is a really hard challenge. But you can figure it out. So normal, next Wednesday by midnight in your GitHub, directory week 9, Python program spiral.py. The Canvas submission will be the URL to your code. Starting with the number 1, and moving to the right in a clockwise direction, a 5x5 spiral is formed as below. 1, 2, 3, 4. I don't know if you can see my mouse. 5, 6. You see I'm kind of snaking out and building this spiral. When I build my 5x5 spiral, the sum of the numbers on the diagonals is 101. We'd have to figure out if that 1 is being counted once or twice. I don't know the answer to that. I haven't figured that part out yet. But given that structure, the sum of the diagonals in this case is 101. With me? What is the sum of the numbers on the diagonal for a 501 by 501 spiral formed in the same way? Obviously, 501 by 501 spiral is too big to do manually, but I want your code to do this. So, figure out your steps. Figure out the logic and come up with the answer. I want your program to just use the print statement to print out the answer. Don't print out anything else. You can debug. You can use the logging function if you want to debug some stuff. Do I have the answer? No. I haven't programmed this yet. I'll do it today or tomorrow. But I will have the answer for you. But I'll be obviously reading your code to make sure your code does it right and doesn't just print out the number. Because if I put an announcement on Canvas and at 11:55 on Wednesday and say, "Whoops, I didn't mean 501. I meant 2,312." Your code should be able to be changed to near instantly to do that. Fair? Think it's gonna be easy?
It's gonna be fun.
I think so too. I think it's gonna be fun too. I've like pictured this in my head a couple of different ways, and I'm looking forward to solving this problem too. So I expect it to be challenging, and if you don't get the answer, good, suffer. If you don't get the answer, that's gonna be okay. Now, to get full credit, you need to get the answer, obviously, but I'm gonna be very nice on grading this one. All right.